All right, so we're going to end the chapter with our final video. And I do want to mention a little bit about electrical synapses just because we need to compare and contrast them with what we've been talking about with chemical synapses. Now, chemical synapses involve those neurotransmitters. Electrical synapses have no neurotransmitters. So if you look here, it says that they have structures in their cell membranes called gap junctions that allow ion currents to flow back and forth. So if you look at this, we're going to have a flow of ions through the cell membrane, and they can flow back and forth. This flow through these protein channels is an electrical current. So that's why we call this an electrical synapse. These proteins that allow the movement of the ions are called gap junctions. And really, where we find this is the heart. So our heart is not using a neurotransmitter to move their action potentials. They're moving these electrical synapses. All right. So when you think about electrical synapses, you just have to think about the heart. This is how the heart is working. When it comes to our brain and our spinal cord and all of our nerves, we are using a chemical synapse with these neurotransmitters. All right. So let's wrap up this chapter. One other thing I want to mention, our nervous system can produce proteins called neuropeptides, and they are proteins of about 3 to 40 amino acids. The one I really want to mention is this neuropeptide that our nervous system, our neurons produce, called substance P. Substance P is a neuropeptide that's going to enhance our perception of pain. So when you get injured, the neurons involved at the injury are going to produce substance P. Substance P gives you that perception of pain. So it says they're released by the sensory neurons, and they're going to cause you pain. So the more substance P you produce, the more pain you have. Now, this goes into some pain relief. Let's look at pain relief a little bit. Various pain relievers. It says enkephalins, endorphins, dynorphins, opioids. These types of medication are going to block your pain by blocking substance P. So what we do is we block the substance P from being produced, and that stops or alleviates pain. All right. The big one here that I want to mention is opioids. Opium is a inhibitor to neuropeptides, to substance P. So opium is going to block substance P. That's why things like morphine, which contains opium, morphine is an effective pain reliever because it blocks substance P. Now, we produce natural opioids. So we produce endorphins and dynorphins, which are opioid-like, and our body just naturally produces these. This is why acupuncture works. So with acupuncture, actually what we do is we create some pain in that area that we want to treat by poking you with a needle. That needle causes pain. When you are subjected to that, your body produces endorphins and dynorphins, these opioids, which are then going to block substance P. A good example of this also is when you go and get a tattoo. So tattoos, they are stabbing you with a needle. That tattoo gun is a needle. And if you've ever had a tattoo, you'll notice that when you first start the tattoo session, you're in a lot of pain. But as that tattoo progresses and as you keep getting stabbed with the needle over and over again for a longer period of time, your pain deadens. That's because your body's producing these opioids, which are preventing substance P from being produced. And by the time, your tattoo session is over, you aren't feeling that pain you felt when you first started. The same thing is going on with acupuncture. Now, if you know anything about opioids, though, you know that opioids are addictive. They produce addictive qualities with your dopamine. So anytime you release these opioids, you get this pleasurable feeling as well. And this is often why tattoos can become addictive. When you are getting a tattoo, you're releasing these opioids to block substance P, but you're also stimulating dopamine, which makes you feel good. I remember going out of the tattoo place after a long session a couple of times, and you feel just really good because you have all these opioids in your body, these dynorphins and endorphins. Exercise also produces endorphins, which is why exercise can be addictive as well. You want to keep doing it because you're releasing these opioid-like substances. But substance P is going to cause our perception of pain. Now, some people naturally produce more substance P than others, and that's why they may be more sensitive to pain, whereas other people produce less substance P, and they may not have that perception. Substance P levels rise when people are in pain. So we can find substance P and sample it in places like your cerebral spinal fluid. And that's how they can make various diagnoses. It says like fibromyalgia here. Fibromyalgia is kind of a mysterious pain that is hard to diagnose, but we can actually tell that someone is in pain by the amount of substance P that's in their nervous system. So that's just an example. So neuropeptides are pretty interesting. These last couple of slides are just kind of summary things. Neurons can branch. They have different pathways. So convergent, we have nerves coming together. So as the nerves come together, they are coming together and fusing together. Those are convergent. Divergent is where they're splitting apart. So a lot of motor neurons, they're branching out, going to different areas. Those are divergent. And then we have oscillating circuits, which can repeat and just repeat themselves over and over and over again. And here's an example of an oscillating circuit. So you can see here we have an action potential moving down our neuron, and then we have a collateral, the side branch, that can kick that action potential back the way it came. And so we can have these oscillating circuits where we just have the same action potential repeating over and over and over again. So it says oscillating circuits can involve positive feedbacks. So it says they involve rhythmic activities like swinging your arms when you're walking or breathing. These are oscillating, repeating motions, swinging your arms or breathing. And so they involve these oscillating circuits. Okay. Just to mention a a couple of diseases here to end the chapter. Epilepsy is a neurological disorder. It says it affects 1% of our population approximately. And here is the definition. So it says it's an abnormal synchronous discharge of neurons in the brain. So there's action potentials that are occurring in the brain that shouldn't be. That, in a nutshell, is epilepsy. Now, a lot of things can trigger an epileptic seizure. Things like lights, noise, smells, something that's being sensed by the body triggers these abnormal synchronous discharges of action potentials within the brain. During an epileptic episode, skeletal muscles may contract. The person may lose consciousness. The thing that we need to realize about epilepsy is a symptom of something else. It's not a disease that stands on its own. It's a symptom that something else is wrong. So a person that is having an epileptic episode has some underlying condition that's causing that epilepsy. People don't just have epilepsy to have epilepsy. There's something else causing it. So it says it could be something like brain damage. It could be some metabolic disturbances. For example, neurotransmitter issues. Someone's making too many, someone's not making enough. It could be an infection. It could be a toxin. It could be vascular disturbances. Vascular means blood vessels. So maybe there's not enough blood flow to an area, and that's causing the epileptic episode. It could be an injury. It could be a tumor. So it is there's an underlying cause to epilepsy. It's not a standalone disease. All right. And then finally, I just wanted to mention multiple sclerosis because it is a neurological disease that involves our myelin. So it says it's an autoimmune disease that causes the destruction of that myelin insulation in our central nervous system. So those oligodendrocytes that made our myelin, the myelin's being destroyed by our own immune system. Anything that's an autoimmune disease is when our own body is attacking our cells for some reason. Now, normally we've got receptors that are going to tell our body from a foreign invader, so our immune system doesn't attack ourselves. Well, there's a mistake made in an autoimmune disease where the immune system mistakes our own body for a foreign invader. This occurs with multiple sclerosis, where our immune system attacks the myelin sheath around the central nervous system. All right, and you can imagine if you're losing that insulation, you're going to have some problems. So it says these myelin sheaths become scars and plaques. Interestingly, there's some statistics here. 500,000 people in the United States are affected by MS. You probably know someone, and it says it appears usually between the ages of 20 and 40. So it's younger people that tend to get multiple sclerosis. And I don't know what the reason is. It's a genetic thing, but women are twice as likely as men to get multiple sclerosis. In fact, I think about all the people that I've known through the years that have had MS, and I think they've all been women. I don't recall a man that I've known firsthand that has had MS. Maybe that's a coincidence, but females are twice as likely. So what happens when you lose this myelin? Well, symptoms it says includes muscular weakness, abnormal sensations, things like double vision can occur, and it can end up with paralysis, and then the nervous system failing and the person passing away. Multiple sclerosis can have remissions and then relapses, but it's a progressive disease. It's progressive and cumulative. Now, this is a good time to just mention what the difference between a remission and a cure is. If someone is in remission, that means that they still have the disease. It's just not getting any worse. So if someone says that my multiple sclerosis is in remission, it means that they still have multiple sclerosis. It's just not getting any worse. Now, they can have a relapse where the disease progresses and they do get worse, and then they can go into another remission. The issue with this is when someone's in remission, they cannot get any better. They don't get worse, but they don't get better. And so there's not a cure for this. A good example of remission is cancer sometimes. People will say that their cancer's in remission. That doesn't mean that they are cancer-free. It means that their cancer is not progressing and getting any worse. Same thing with multiple sclerosis. All right, I just wanted to mention that as it's kind of important to know what that word remission means. All right, so we are done with this chapter, and we're going to move into chapter 13 next, but we're making progress. So any of you have any questions, please email me. I don't get a lot of emails, so hope everyone's doing well, and I will see you for the next chapter.